that light bulbs that cost €2. Okay? Now, I'm going to take us back to the objective, which said using ratios and things like that. You've done a graph. All of your graphs are what? How do you describe them? We talked about this last time. And
Straight.
so straight lines with a line. They've got perfect correlation, right? Because it's a function, all functions, but they are positive gradient, right? Okay. Now, I just wanted to talk about this aspect of it. So if I did a table of values, we've got B and we've got I, bulbs and income. That's not straight. Never mind. Right. One light bulb income is 2.
4.
Okay. If I multiply the number of bulbs by 2, what do I do to the income?
Multiply to 2.
Okay. So if I times that by 2, I times that by 2. If I times that by 6 to get 12 bulbs, I also have to times the other one by 6. And we are starting to look at one of the characteristics of a proportional relationship. Now there is a value here that I've not put in, which is 0, 0. So in the reflect and discuss, you are asked to justify why it goes through 0, 0.
Because at that point, on the graph, you haven't sold any light bulbs yet.
So
you may never.
yeah, simple as that. No light bulb sold, no income coming in. What we can say is that the income is directly proportional to the bulbs that are sold. Do you recognise the notation? The little fishy symbol, right, means directly proportional. However, we can also write this, if you turn over your page to the next pink box, we can also write that as I equals A, B, where this fishy symbol, meaning direct proportionality, because that isn't anything, we don't work with it mathematically, we can replace that with equals K. Now K is called the what? Is it?
Proportional.
So it's the constant of proportionality, constant variation, yeah. So K is that value. Now how do we find K? Well, you wrote a function for this one, which was income equals 2B. Yeah? Okay. I could also write it as B is proportional to I, therefore B equals KI. B equals
K.
What's K?
2.
Half of I.
Oh.
Look at it. If I spend $16, how many light bulbs did I buy? 8. Yeah. If I spend $50, how many light bulbs did I buy? 25. Half that. If I bought 30 light bulbs, what's my income? 60. Yeah. Depending on which. So our proportional relationship can be written both ways, where the constant proportionality can be depending on which way around you look at it, right? But important is the notation, knowing that K is the constant of proportionality. And you will see that when you look at your ratios times the constant of proportionality, if we go that way. So it's always times 2. That's the relationship. And with light bulbs, make perfect sense, right? It's $2 a light bulb, always times by 2. Is it ever going to be anything different?
No.
No. If it's something different, someone's trying to scam you. Unless you buy a different light bulb. The other light bulb is €7. So my table is 0, 0, 1, 7, 2. You notice how I'm writing it now? I equals 7b is the function you should have written, because we know that I is directly proportional to b. I equals kb. K is the constant proportionality, can be seen because they are linked in that way. Okay? It's always times 7. What does a graph look like? Well, both of your situations will look like the first one. If I put 0, 0, but just to show you, it looks a bit like that, right? Maybe you have different scale. The second one looks like yeah?
Yeah.
Should I draw a line through them? Yeah, good. It's not infinite number. You can't buy half a light bulb. Good. So we shouldn't really. What kind of data is it? Anyone remember?
Domain.
It's simulation. This compilation.
There's proportions.
This is discrete.
Do you remember we had discrete or continuous data? This is discrete. Every light bulb is its own amount. Okay. So is it true that every straight line shows a direct relation? What? You've just gone, no, because yes. Any answers? Is everything that gives a straight line?
I mean, if we're talking about cost, they might have like a discount or something.
Oh, okay. So, for instance, if you buy 10 light bulbs, you get €1 off. Would that mess up our relationship? Would that no longer be Australian? One thing I've got to say to you though, let's consider this one. So here's the table of 2 things. I'm going to write it like this. Let's just do A and F. All right. Let's say let's do 1 and 3, 2 and 7, 3 and 11, 4 and 15, 5 and
27.
19.
19. Thank you. All right, how have I continued that? I've added 4. Right. Can you please tell me, is this statement true? Have a think, have a talk to the person next to you about this, not just that in it. I can definitely confirm that if I plot F against A, we will get a straight line, just like the others. However, that does not answer the question. Is A directly proportional to F? No. What? You say yes.
We can't simplify any of them to the same ratio.
Like that approach. I've left a gap here. What should go there? Well, it will be 0, -1, won't it? Well, because so this one does not go through its origin. Now, if we were to consider that in our light bulb situation, if I walked into a shop and the shopkeeper went, hang on, how many light bulbs you got? Not touch any light bulb, mate. You owe me €1 then. Doesn't work, does it? If I've not got any light bulbs, you're not having any of my money, right? But this would suggest I've not bought any light bulbs, but I owe them a euro, right? Or if it was the shop, I lose €1. But if I buy one, it costs me 3. So of course that makes perfect sense. If I buy 2, it costs. If I buy
one, like go back, buy one.
it's like now.
That's good marketing.
This shows a definite linear relationship. So some of you might be able to work out F equals skill you should have.
A or negative plus B. A or negative K, K,
Oh yeah,
A plus
negative, it's
4.
4x minus
4a minus 1. Okay, 4x minus. mx plus c, remember gradient, rise over run, 4 over 1. Rise over when we did that, where does it cross? Crosses at -1. Did that. Now, if it, and as you have already mentioned, there are 2 ways to know. Izzy, do you want to look like you actually want to be here? I know you don't. Sit up. Look tidy and zen. Some sort of something. Okay. There are 2 things that we have to have for a direct relationship. One is, it must go through 0, 0. So this automatically says not. It must be a straight line, but remember, for it to be directly proportional, in this case, I should have F equals KA, and that's it. What does the K represent? The K should represent what you multiply by, yeah? So in this case, it's multiplied by 3. This one's multiplied by not 3. Neither's this one, neither's. The rest aren't. So there is no, what's it called again? K stands for? Constant. And what is this one not? Constant. Therefore, this is a linear equation, gives a straight line, but it's not directly proportional. Okay? That's the important bit. So, we should write this. I know you've already got it in on your paper, but we should write it. A directly proportional relationship must have 0, 0 in the table. Okay. And I'm going to go with what Hugo said. All ratios should be equivalent. So that would give you the constant of proportionality. So I will come back to this so you can write it. You can see here, look, 1/7, 2/14, 3/21. They're all the same ratio, just simplified. Whereas 1/3, 2/7, 3, they're not. Now, one of the reflect and discuss is, could you give me an actual situation that is a linear relationship but not a directly proportional one? this world of money, think of services that you might get. Yeah.
What is that, word saying next to the whole in the second half?
Ratios.
Oh.
You want to think about it? How about calling out the plumber? The plumber charges you $200 an hour. I don't know whether that's true. It's not far off. If a plumber charges you $200 an hour, is that a proportional relation? Yeah. If they don't work, you don't pay them. They work 1 hour, you pay them 2 hours. What is it about plumbers though that makes it not a proportional relation? No, that's still a proportional relation. That's a continuous one. A plumber, they could say, well, I've only worked a quarter of an hour, just give me $50. That's all right. Plumbers do something different. They have a call-out fee. So when you call a plumber, just for them to arrive might cost you $50. Pay for their petrol and stuff. And that's the same for every time. Now that is the, do you remember what this number here was called? The initial condition. So if we have an initial condition that is not 0, we no longer have a proportional relationship. That makes sense? So a plumber, you call them out, they go, right, $50 and I'll be there. Right, now what do you want me to do? Right, to do that job, I will charge you $200 an hour. Right, great. $200 an hour, but plus the 50. That brings the proportional relationship.
But if you don't have the supplies that they need, wouldn't you also have to give them money so they could go to like Gorms and get what they
No,
need?
that's involved in their charges normally. Depends how they work. If it's a friend of a friend, they might say, I'll come and work for less, but you provide all the materials. If it's a normal plumber that you're just employing, they'll be like, it's going to cost this much, and I'll provide everything. And if they get it wrong, up to them. You know, they should give you a quote. But often they go, oh yeah, I quoted you 500, but it's actually 3 million. Sorry. Yes.
Could this also work with like someone like cleans your house? Like you have the cleaning stuff ready bought.
Yeah, I mean, you could say that. They're going to charge you $10 an hour for cleaning. Not saying cleaners should earn less than plumbers, like that. But you might consider the fact that you've got to have bought all the cleaning stuff beforehand, so it's no longer a proportional relation. So the important thing for you to be aware of is a directly proportional relationship. Here is the notation. Gets replaced with equal K. There is no plus or minus anything in a proportional relationship. And K is called the? Okay, so looking at this problem just quickly, very quickly. A shop charges €1.50 for a litre of mineral water. Write down the functions, represent the relationship. So we would start with defining our variables. Represent the relationship between number of litres. What are you going to represent that as? L, if you like. Okay, that's the number of litres. And the other variable is total price. So P, the price. Write down a function. So are we going to say that price is directly proportional to the number of litres? No? So we're looking for that. Or should we do it the other way round? Which way round should we do it? Oh, Sammy, when you asked to come at lunchtime and write stuff down, I didn't say no. You closed your book early. You can get that. Which one? Which one works? So price equals 1.5 L. Every litre is 1.5 euros. Right, there's your function. Determine the proportionality constant. K equals
1.5.
1.5. Show that the number of litres and price are in direct proportion by drawing a graph. Well, what would it look like? Would it go through 0, 0?
Yeah.
Why?
Goes direct.
Because they haven't sold any more.
You haven't bought any water. Not going to cost you anything. So 0, 0, tick. Would it go up in a straight line? Because every bottle of water costs $1, €1.50, $1.50. How could it be ruined? In this case, it would be ruined if, like Nico said, I offer you a discount on, if you buy 6,
Get it?
we'll give you a discount. So that word discount or anything could ruin a proportional relationship. Be aware. Nice and easy. Next lesson we'll move on to indirect proportion.